Hello, today we are solving multi-step equations. So we're moving on past our one step, past our two step, and we're gonna get into 3, 4, and sometimes 5-step equations. So we're really amping things up. But before we do that, I want you guys to try the 2 you try now problems at the top. So pause your video now. So hopefully example number 1, you got an answer of b equals -11. All you had to do, this was your one-step equation. And I know the directions, I realized I said one step. I should have said 1 and 2. But this one, number 1, was a one step because you add 12 to both sides. When you do that, this one, -12 plus 12, ends up canceling, and you're just left with b on the left-hand side. And -23 plus 12 equals -11, which you get your final answer of b equals -11. Now remember, you can plug that back in and see if you're correct. If I take, and I'll use a different color, if I take -12 plus -11, you actually do get -23, which means you are correct. So moving on to example number 2, here your first step is always to move the thing that's not with the variable, kind of rule of thumb. And we'll kind of explore why that is today. But first step would be to add 4 to both sides. And then last step would be because then you're left with just b divided by 8. So to undo the division, you had to multiply both sides by 8, which gives you your final answer of -32. Now, this is kind of the goal from where we left off yesterday. If you're wondering, you're like, Ms. Hardy, I don't get what we do first or why. And it has to do with the fact that when you solve equations, because of the fact that you're undoing what's happening to the variable, what's happening is that everything you're undoing has to be undone backwards from how we simplify. So think about it. We simplify using order of operations, right? So when we undo and solve equations, we have to undo those steps in pretty specific ways. So think about it, if we simplify using order PEMDAS, we solve using SADMEP. So we reverse the process. If the first thing that we would have done is parentheses, then that becomes the last thing that we would do in equations. Now you're gonna find out real quickly that sometimes we kind of do these steps out of order, just like we simplify sometimes out of order. But the idea is that, especially when you see grouping symbols, we should always use the distributive property first. All right, so just like when we simplify, we would use the distributive property afterwards. When we are gonna kind of start moving terms and combining things and moving things to different sides, we always have to make sure that if there's distributive property, that's the first thing that happens. Which is kind of, I know, backwards because you see parentheses and it shows up last, but distributive property is kind of the one set of parentheses that kind of breaks that rule. So let's actually do our first example. So here it says, obviously solve the equations, check to see if your answer is correct. So let's go ahead and solve. Now, sometimes the solving doesn't always mean let's start undoing things right away. Usually, as a rule of thumb, there's kind of a couple small steps that I will always follow. And the first one is obviously if there's distributive property. Whoa, not an R, DI. All right, if there is distributive property, that's always obviously the first thing that's gonna happen. And you know there's distributive property because there's parentheses. So one thing I'm noticing about my problem is that we don't have any parentheses. So there's nothing that I have to worry about distributing to. So the second thing, before I start undoing everything, is I always check to see if we can combine like terms. Because I find that kind of down the road, if you can combine your like terms together first before moving things, it saves you steps and saves you work, and coincidentally, it makes it easier. So there's kind of 3 main reasons why I like doing it first. Is this the only way to solve equations? Absolutely not. But for example, in number 1, we do have a set of like terms. And when I look at like terms, I look at ones that are on the same side. So like on the right-hand side here, just the fact that I have this -8 plus 2 This, I can actually simplify that right now. Those are like terms. They have the same variable, which is none, raised to the same exponent, which is none. So I can actually do negative 8 minus 2. So I'm going to go ahead and I'm going to simplify that first. If I do negative 8 minus 2, that gives me negative 10. And what now happens is this becomes a one-step equation. It is a two-step technically, but from here on out, it becomes one. Because to solve, there's only one other thing that I have to do to get n alone. So once you do the combined like term step, then I go about kind of solving using SADMAP. Whoa, not a sap. All right, then we go about solving and undoing things, okay? So here, we right now are subtracting 10 from n. If I wanna get n alone, I wanna undo this subtracting by 10. So to do that, I'm gonna add 10 to both sides. When I do that, negative 10 plus 10 really ends up being 0. Negative 9 plus 10 ends up being a positive 1. Okay, now again, if this bothers you, you can flip those around. 1 equals n, I would accept that. If you want to flip those around and write n equals 1, either one of these is a fantastic answer. Now, let's say you weren't sure you were correct. At the end of the day, can you plug it back up in here? Ooh, that was exciting. Can I plug it back up in here? Of course you can. Let's check it out. If I do negative 9 equals, let's plug in n. We're saying n is 1, minus 8 minus 2. Well, let's see if it actually works. Well, it's all subtraction, so simplifying wise, I'm just gonna go left to right. 1 minus 8 is gonna end up being a negative 7. Minus 2 ends up being negative 9, and it totally works. That means this is definitely my final answer. Now, if you're looking ahead at number 2, you're gonna notice this kind of amps up pretty quickly. But if we follow our steps, I think it'll make solving a little bit more tackleable. So first and foremost, we start with step number 1, which is distributive property. And we do have distributive property here because I have a set of parentheses, which means that the number in front, I have to multiply through to each of the terms that are inside. So if I take negative 8 times 6n, that's going to give me a negative 48n. Negative 8 times negative 4 is going to end up being a positive 32. Minus 4 equals 316. Okay. So now once we do this, we say, okay, well, I'm going to move on to step 2, which is combine like terms. And I'll add same side just to clarify. So yeah, there's things on the right-hand side. There's only one number on the right-hand side, but I'm going to focus on the left side. And I'm going to say, okay, well, do I have any like terms? And hopefully you're saying yes, because I have numbers. I can actually do 32 minus 4. If I do 32 minus 4, I'm just going to keep the 48n there. It's going to chill for a second. 32 minus 4, that was going to end up being a positive 28 and bring everything else down. Now, there's no more like terms on the same side. Now we go about solving and undoing. So because I have an option between undoing multiplication and undoing addition, in terms of using SADMAP, we undo the addition or subtraction first. Basically, anything not with the variable is usually something we're going to tackle getting rid of first because it's easy. Like right now, if I'm adding 28 to all of this, I'm going to have to undo that by subtracting 28 to both sides. So on the left-hand side, positive 28 minus 28 cancels out, which is what I'm looking for. I'm looking for that to go away. So if I add 28 to both sides, is that something you can do? Yes, but 28 plus 28 doesn't cancel. That becomes 56. So just be careful. You can add anything you want to both sides, but you're looking for the number that's going to end up canceling it out. So 28 minus 28 ends up canceling out to 0. You're left with negative 48n equals 316 minus 28, which becomes 288. And now last but not least, now I have only one more thing to undo and is not solved for until I undo that multiplication with division. And the nice thing is negative 48 divided by negative 48 ends up being 1, which you can write if you want to. We don't always write it. Most of the time I won't, just so you guys know. But on the other side, 288 divided by negative 48 is going to end up being negative 6. Wow, that -6 went crazy. There we go. And we have our final answer, which of course you could plug back into the top and check. Hopefully you guys believe me that I checked it for you already, but n equals -6 is totally the correct answer. Okay. So what I want you guys to do right now, pause your video, and I want you to try example 3 on your own. Okay, hopefully final answer, you should have got k equals 2 or 2 equals k. Either one is fabulous. This one uses all the steps. Again, my first step is going to be distributive property, which is the first thing that I did. Okay. Second step is going to be that combining like terms, which I also did. Once you distribute, you actually are left with an 8k plus 2k, which can simplify down to 10k. Okay. And then last but not least, then we just kind of go through all of our opposite steps. Again, usually whatever's not with the k. So like usually it'll be something that's like, if k is being multiplied or divided by something, that's always the last thing that we'll do. So for me, my first step was to undo this adding by 20. So I subtracted 20 to the other side. And that left me with only one last thing to do, which was to undo the multiplying by 10 with division. We divide both sides by 10, which gives you your final answer. Okay, so I'm going to pause the video. If you want to try some of the try nows, go for it. You would pause now though if you don't want to, if you want to try some without seeing the answers, but answers are coming up now. All right, so just be aware, number 3, you actually do get a fraction. If you wrote your answer as a decimal, remember we do not write answers as decimals unless it's a word problem, okay? So number 3 doesn't turn out to be the nicest, but you should have gotten 43/3 as your answer, okay? Now, if you have questions, obviously this is the time to mention that if you do have anything that you have questions on, you can always meet Miss Hardy in office hours and she will go over it with you, all right? Good luck, and you may move on to the practice.